was accidentally brought in shortly after World War II and has eaten all of the native forest birds and driven some species and subspecies actually to extinction.
Imagine helicopters releasing thousands of dead mice treated with pain relievers into one of North America's most delicate ecosystems. It sounds unreal, but it's a real plan to combat a growing crisis in Florida. Why take such an extreme step, and what consequences could follow? Burmese pythons have taken over the Everglades, resisting nearly every control method. Now, researchers are testing poisoned bait targeting young snakes. But in a system this fragile, even a solution like this could trigger unintended effects across the entire food chain. The python problem unfolding. In Florida's Everglades, a hidden invader has quietly taken hold and reshaped the ecosystem in profound ways. The Burmese python, an apex predator native to Southeast Asia, now slithers unseen through the dense sawgrass and waterways of this vast wetland. Since at least the early 2000s, these snakes have spread widely, preying on native mammals, birds, and reptiles with devastating efficiency. Despite sustained efforts, including professional removals, state-sponsored hunting contests, and private night hunts, the python population shows no meaningful signs of shrinking. In fact, the numbers suggest the opposite. The pythons are breeding faster than they can be caught. Tracking the true population size is nearly impossible because these snakes are masters of concealment. They blend seamlessly into reeds and water edges, often moving silently beneath the surface. Hunters spend countless hours searching, only to find a handful of snakes in return. On average, it takes agencies and hunters about 12 collective hours to track down a single python. This is time-intensive and resource-draining, yet far from enough to outpace reproduction. A single female python can lay up to 100 eggs in a single clutch, fueling rapid growth that outstrips removal efforts. This constant undercurrent of failure has forced wildlife managers and scientists to question conventional approaches. Trapping fails because pythons don't behave like typical prey animals and often reject bait. Poisoning is not an option either, as the Everglades is a delicate ecosystem teeming with diverse species, most of which would be affected by toxic substances. The snake's very invisibility, its ghost-like movement, and remote habitat make it almost untouchable. With each passing year, the problem deepens, prompting a search for a more radical and perhaps riskier solution. In the meantime, the cultural and ecological damage continues. Small mammals like raccoons and opossums have seen population declines nearing 90% in some areas. Ground-nesting birds vanish without a trace. The Everglades' intricate food web feels the weight of these losses, imperceptibly shifted by every python silently swallowing prey whole. The balance of this unique wetland is being rewritten, and the rapid expansion of Burmese pythons is the epicenter of this crisis. As the python population grows, so does the urgency to rethink wildlife management. Researchers are increasingly drawn to ideas that reject standard hunting and trapping, because those methods simply cannot keep pace. Instead, they are turning to the food supply itself, asking if it can be weaponized against the snakes. But even this approach carries uncertainties, especially in a place as ecologically rich and interconnected as the Everglades. The unfolding crisis demands more than just brute force. It requires creativity, balanced with caution. One might wonder how a species capable of consuming deer whole could ever be targeted by something as small as a mouse. Yet, the biology of different life stages holds clues. Juvenile pythons, much smaller and more nimble than their massive adult counterparts, hunt prey the size of rodents. This detail opens the door for alternative tactics, but only if deployed thoughtfully and at a scale large enough to matter. The challenge is mounting: how to deliver a lethal strike to the next generation of pythons before they become unstoppable adults. Such questions linger in the background as government agencies begin collaborating with researchers on a bold plan, one involving helicopters dropping thousands of small baited mice into the tree canopy. But this method is not as straightforward as it sounds. The complexity of the Everglades means every action could ripple unpredictably across species and habitats. That reality hangs over the project like a shadow, reminding everyone that in ecology, there are rarely simple answers. The stakes in South Florida are not only ecological, but deeply cultural and economic. The Everglades is a national treasure, home to hundreds of bird species, a myriad of reptiles, and countless mammals. Efforts to preserve this landscape have long centered on maintaining balance for both nature and the people who depend on it. Yet, invasive species like the Burmese python upset this balance on a grand scale, threatening to erase centuries of natural heritage. The question is whether the next moves will restore order or unintentionally accelerate decline. Understanding the scale and difficulty of this problem sets the stage for a surprising and controversial solution. To grasp why billions of dead mice might soon fall from helicopters across the Everglades, we need to look back thousands of miles and decades into another island's struggle with invasive snakes. That history carries lessons, a cautionary tale that may hold the key to Florida's dilemma. Transitioning from Florida's crisis, a remote Pacific island once faced a similar nightmare, offering insight into what aggressive intervention can achieve and the dangers it may bring. Lessons from Guam's snake crisis. Nearly 8,000 miles from the Everglades lies Guam, a small island in the western Pacific that shares a surprisingly dark connection to Florida's python problem. In 1952, the brown tree snake arrived on Guam, accidentally transported in military cargo after World War II. At first, the snake seemed unremarkable, only about 1 meter long, mildly venomous, and not threatening to humans. Early wildlife researchers barely noticed it, assuming it posed little risk. But over the following decades, this assumption proved tragically wrong. Guam's native birds had evolved in the near-total absence of ground predators. They nested low in the trees or on the ground, and had no instinct to flee from snakes. This evolutionary naivety allowed the brown tree snake to become a stealth predator and biological wrecking ball. Within decades, bird populations collapsed dramatically. 12 species stopped breeding entirely on the island, and 8 more saw their numbers plummet by over 90%. Birdsong, the soundtrack of Guam's forests, died out almost completely. The ecological damage extended beyond the disappearance of bird species. The island depends on these animals, which function as important seed dispersers and pollinators, to maintain its forest structure. The island's ecosystems started to collapse when these vital organisms disappeared from their natural habitats. Guam demonstrates through its historical events how invasive predators eliminate native species, while native ecosystems of islands face imminent extinction. The brown tree snakes generated 200 power outages annually because they climbed power lines, which caused transformers to short-circuit, leading to economic losses of millions of dollars. Scientists worked at full speed to develop a solution that would protect nearby islands from experiencing the same destruction that had already occurred. The research team made an unexpected finding when they discovered that acetaminophen, which serves as a common household pain reliever, produces lethal effects on brown tree snakes. An average adult snake dies from just 80 milligrams of venom because it causes complete liver function failure. The discovery established a new method for researchers to develop an animal control system that uses bait to capture snakes while protecting other animals. The jungle lacks any practical solution that allows people to distribute pills through its forested areas. The scientists created a system that enables them to hide acetaminophen inside dead mice. The scientists developed a system to release baited mice, which they attached to lightweight cardboard streamers that would become stuck in tree branches where brown tree snakes hunt. The helicopters released thousands of baited mice, which covered the affected jungle areas. The field tests produced impressive outcomes because snake populations decreased by up to 80% in treated areas following just one treatment. The method proved to be both expandable and cost-efficient. The system performed better because it used specific methods that achieved better results than both traps and hunting. The system required snakes to use their natural prey-finding abilities, which included their preference for rodent hunting and their method of climbing trees to hunt. The Guam operation succeeded through its innovative application of biochemical weaknesses, which used a common medication to successfully remove an invasive predator. The lessons from Guam offered hope that other snake-plagued ecosystems might be next. The state of Florida received from Guam's story the important knowledge that all creatures exhibit physical weaknesses that extend beyond their venomous capabilities. The existence of a substance that common people can access through pharmacies shows that invasive snakes develop similar liver disabilities to those that affect snakes. The scientific shift led to the creation of an unprecedented wildlife management study, which became the first of its kind to take place in North America. Guam's success presents potential advantages, but it brings up challenging issues that involve both risk assessment and assessment of both potential impacts and system growth. The Everglades of Florida present complicated solutions that exceed the simple solutions that follow most straightforward paths. The research continued because the scientists investigated an active substance that people commonly know as acetaminophen. This leads us to the heart of Florida's experiment and the science behind why dead, medicated mice dropped from the sky might finally change the game against invasive pythons. Why acetaminophen and mice? Acetaminophen, commonly known by brand names like Tylenol, is a pain reliever that almost everyone recognizes. What makes it deadly to invasive snakes like the brown tree snake and, critically, the Burmese python is a specific vulnerability in their liver enzymes. These snakes lack the metabolic pathways that animals like humans use to safely process the substance, so even relatively small doses cause fatal liver failure. This discovery was pivotal because it revealed a biochemical Achilles' heel shared across certain snake species. Targeting this vulnerability required a delivery method that fits snake behaviors. Snakes don't seek out poison or traps the way mammals might. Instead, they follow prey cues, hunting rodents, birds, or other animals they naturally consume. Scientists reasoned that embedding lethal doses of acetaminophen inside prey items would trick the snakes into taking their own medicine. But how to do this across vast and hard-to-access wilderness? The solution was surprisingly simple and elegant. Dead mice injected or stuffed with a carefully measured dose of acetaminophen. These mice become irresistible bait for snakes that hunt small mammals. Attaching each mouse to a light cardboard streamer causes them to catch in the tree canopy instead of falling to the ground. This is crucial because many snakes, especially juveniles, hunt not just on the forest floor, but in low branches, moving vertically through vegetation. Researchers use helicopter drops of baited mice into the Everglades to achieve fast coverage of vast remote areas. A single helicopter mission enables the delivery of multiple thousand bait cartridges, which results in the release of more than 20,000 poisoned mice. The aerial method establishes a direct path for operations that traditional hunting and trapping methods had found challenging to execute. The method achieves its goal of tracking hidden python territory through its ability to expand beyond any previous method. The strategy aims to capture juvenile pythons, but it does not target their adult counterparts. Adult Burmese pythons reach a maximum size of 16 feet and 165 pounds, while their diet excludes small rodents. Their diet expands to larger prey like deer, raccoons, and birds. Juveniles, however, start exploring their environment by climbing trees to search for rodents that match the bait mouse size. The toxic bait approach exists as a biologically feasible control method because of the different behaviors exhibited by the species. Researchers at the University of Florida confirmed that Burmese pythons and Guam brown tree snakes face the same metabolic vulnerability to acetaminophen. The discovery resulted in building support for testing the mouse drop concept within Florida's Everglades, because scientists aim to achieve the same snake population decreases that occurred on Guam. The Everglades ecosystem, which contains multiple native species, raised worries about potential environmental effects because various animals would consume mice that contained the toxin. This tension between a promising tool and its complex consequences draws us deeper into Florida's unique challenge, where every solution carries its own shadows. No solution exists in isolation. Each decision sends ripples across interconnected lives, making Florida's fight against pythons a story of both hope and caution. Targeting juvenile pythons. One of the most important insights driving the mouse drop strategy is that juvenile Burmese pythons behave very differently from their enormous adult counterparts. While adults can grow up to 16 feet long and weigh over 160 pounds, making them too large to be interested in tiny mice, young pythons are a different story. Hatchlings and juveniles in their first 1 or 2 years are about the same length as adult brown tree snakes and prey primarily on small rodents. This size and dietary difference make juvenile pythons vulnerable to baited mice, turning a mouse into a potential delivery system for their downfall.
Juvenile pythons are also much more active climbers. Unlike adults that spend most of their time on the ground or in water, young snakes move through low branches and dense vegetation in the tree canopy. This vertical habitat overlaps perfectly with where mouse baits suspended on cardboard streamers end up after being dropped from helicopters. The bait is designed to catch in the canopy, making it accessible to juveniles who are naturally inquisitive and constantly exploring their environment. This behavioral detail is crucial. It means the strategy isn't simply a guessing game, but tailored to snake biology. Researchers at the University of Florida ensured this dynamic was central to the approach. Herpetologist Dr. Kristen Hart spent years tracking juvenile pythons using radiotelemetry, attaching tiny transmitters to neonates and following their movements through terrain that hunters could barely navigate. Her findings confirmed that these young snakes are active, curious, and frequently climb, making them likely to encounter the baited mice. This direct connection between behavior and bait placement offers a rare degree of precision in wildlife control. The math behind targeting juveniles is powerful. Female Burmese pythons lay up to 100 eggs per nesting event, and preventing a sufficient number of those hatchlings from surviving to adulthood can halt or even reverse population growth. The mouse drop strategy aims not to slay the massive adults already causing damage, but to curb the next generation before they reproduce. Slay enough juveniles consistently and across the landscape, and the population stops being replenished year after year. There also remains the issue of variability within juvenile python behavior. Not every hatchling moves through the canopy with the same frequency, and prey availability fluctuates seasonally. This means some juveniles may not encounter the bait or may choose alternative prey. Yet, the consistent presence of rodents in the Everglades suggests that baited mice could form a reliable food source, especially for the smallest snakes struggling for calories in a competitive environment. While juvenile pythons are biologically vulnerable to this poison bait method, adult snakes remain out of reach. Their prey preferences and sheer size render mice irrelevant. This divide means the mouse drop strategy is not a silver bullet. It's a targeted population control tool focused on reducing recruitment rather than eliminating current adults. The full consequences for population trends will depend on whether juvenile mortality can consistently exceed reproduction over many years. Scientists remain cautiously optimistic, but aware that this effort only addresses part of the complex python challenge. Juvenile mortality must be significant and sustained to outpace the species' tremendous reproductive capacity. Meanwhile, adult pythons continue to lurk, hunt, and breed. The mouse drops represent hope focused on the future of the Everglades, an attempt to tip the balance on a scale no one has been able to reach before. The Everglades' biodiversity and size bring us face to face with questions about how a massive bait drop campaign might interact with everything else living in this intricate wetland. Overscale and ecosystem complexity. The Everglades is one of the most biodiverse and interconnected ecosystems in North America, home to more than 350 bird species, over 60 reptiles, 40 mammals, and 50 species of fish. It's an ecological tapestry woven from countless interdependencies. This natural richness is a strength, but also a formidable challenge for any large-scale intervention, especially one involving the dispersal of millions of acetaminophen-laced mice. When poison enters such a complex web, every thread is at risk. To make any impact on juvenile pythons across South Florida's vast wetland, researchers estimate millions of these medicated bait mice would have to be dropped multiple times annually. The scale is almost unimaginable, with helicopters flying long routes methodically releasing thousands of target baits caught in the canopy. Yet, once these mice fall from the sky, control over their fate diminishes. The Everglades is a shared home to scavengers, opportunists, and predators that don't discriminate based on scientific intent. The process of secondary poisoning makes the system more complicated. Acetaminophen remains in raccoons and squirrels after they consume toxic mice and survive the encounter. Predators such as owls, hawks, and eagles that feed on these mammals then ingest the toxin indirectly, risking illness or death, especially among vulnerable nestlings. The cascading effects of this event create unpredictable pathways that move through the food chain, making it impossible to measure the outcomes during risk assessment procedures. The entire biological system of the Everglades faces danger from its fundamental structural components. Birds of prey, like bald eagles and red-tailed hawks, although not primary hunters of mice, may still feed them to their young during lean seasons or when other prey is scarce. Adult raptors do not find one mouse deadly, yet nestlings tend to handle much lower amounts. A generation of failed nests caused by poisoned food brought by parent birds could result in sudden and dramatic declines in these apex avian predators. Population surveys show this process starts to reveal its effects only after several years of time. The potential consequences of this issue create high levels of concern for the Florida panther, which ranks as one of the most endangered large cats in the entire world. The panther population has decreased to fewer than 120 adults, who now occupy a limited territory that intersects with the python habitat. Unlike other predators, panthers actively hunt for dead animals to eat, which makes suspended dead rodents in the understory an available meal. The eastern indigo snake, which serves as Florida's longest native snake and natural predator of juvenile pythons, represents a native snake. The indigo snake population has decreased because people destroy their habitats, but this species functions as one of the few natural controls that maintain python populations. Indigo snakes consume mice, but they face the risk of poisoning through their contact with poison bait. The ecological impact of their sensitivity to acetaminophen remains unknown, which creates additional uncertainty about their environmental effects. Pythons will distribute their baited mice throughout water bodies because they spend half their time in water, and their prey is found in aquatic environments. Aquatic species, including native fish and snakes, may eat poisoned mice, which introduces toxins into the already weakened aquatic food web. Aquatic systems distribute toxins through their environments in unpredictable ways, which makes it difficult to monitor and control environmental contamination. The balance between innovation and caution weighs heavily on every decision moving forward, as Florida searches for solutions that protect not only a single species, but the entire living web of the Everglades. Ecological ripple effects. Introducing a toxin into an ecosystem as complex as the Everglades is never straightforward. Acetaminophen-laced mice are meant to target juvenile Burmese pythons, but once deployed, they become accessible to many other animals. Rodents are a common food source, and poisoned bait can be consumed by unintended species, spreading toxic effects through the food web. These impacts are difficult to track and may continue long after the initial drops. Mammals like raccoons and opossums, already struggling due to python predation, are especially vulnerable. A dead mouse offers an easy meal, but if it's contaminated, it could further weaken or even wipe out local populations. What begins as a solution to one ecological problem risks deepening another, accelerating the loss of native species already under pressure. Secondary poisoning adds another layer of risk. Birds of prey such as owls, hawks, and eagles may consume animals that have ingested the toxin but survived temporarily. These predators can then pass toxins to their young, leading to nest failures or chick deaths. Even when adults survive, sublethal exposure can impair hunting ability, reproduction, and overall health, gradually destabilizing predator populations that play key roles in maintaining ecological balance. Nocturnal hunters like owls are particularly exposed, relying heavily on small mammals for food. Because the effects may appear later, through reduced breeding success or declining health, linking cause and effect becomes challenging. By the time warning signs appear, damage may already be widespread. Perhaps the most alarming risk involves the Florida panther, one of the most endangered predators in North America. With only a small population remaining, each individual is critical to the species' survival. Panthers are opportunistic feeders and may consume dead rodents, making poisoned bait a serious threat. Their bodies cannot effectively process acetaminophen, meaning even small amounts can be fatal. Given that their habitat overlaps with potential bait zones, avoiding exposure would be nearly impossible. Native snakes also face uncertain risks. The eastern indigo snake, a key predator of young pythons, consumes small mammals and could encounter poisoned bait. Already affected by habitat loss, this species represents one of the ecosystem's few natural defenses against pythons. Affected to indigo snakes would undermine long-term control efforts and deepen ecological imbalance. These cascading effects reveal a hard truth. Targeting one species rarely stays contained. The Everglades operates as an interconnected system, where changes ripple across multiple layers. While controlling invasive pythons is urgent, the use of toxic bait risks unintended damage that could rival the problem it aims to solve, underscoring the delicate balance at the heart of conservation. Such complex interconnections bring us directly to a larger conservation conflict: the pressing need to protect native species that could be affected by efforts to eliminate pythons. Conservation conflicts and native species. At the center of Florida's python crisis are native species that both suffer from and help control the invasion. One of the most important is the eastern indigo snake, the longest native snake in North America, and a rare natural predator of juvenile Burmese pythons. By preying on young pythons, indigo snakes provide a valuable biological check on a population that might otherwise grow unchecked. Protecting and restoring their numbers is essential for maintaining long-term balance in the Everglades. Yet indigo snakes have been declining for decades due to habitat loss and fragmentation. They require large, continuous territories, something increasingly scarce in South Florida. To address this, conservation programs have invested in captive breeding and reintroduction efforts, aiming to rebuild populations strong enough to naturally suppress python numbers. Their success could become one of the few sustainable defenses against the invasion. However, a major conflict arises with the use of acetaminophen-laced mice as a control method. Indigo snakes feed on rodents, the same animals used as bait. If they consume poisoned mice, they could be affected or slain. While their exact sensitivity to acetaminophen is not fully understood, the risk is real. This creates a troubling paradox. A strategy designed to protect the ecosystem could end up affecting one of its most valuable native allies. The concern extends beyond indigo snakes. Other native predators and scavengers and insect-eating species will consume rodents or carrion, which will result in their exposure to toxins. Many of these animals face existing threats from habitat destruction, environmental pollution, and climate change. The use of poisoned bait will push some animal populations towards extinction, which will create obstacles for all conservation programs. The process of delivering bait to targets brings environmental hazards. The method of aerial drops prevents complete control, since some poisoned mice will eventually drop into rivers. The Everglades complex wetlands system creates problems for all aquatic species, which include fish, amphibians, and water-dwelling reptiles. The movement of toxins throughout aquatic food chains introduces another unpredictable factor. The overlapping risks create challenges for managing invasive species, which threaten to damage native species in ecosystems that contain diverse wildlife. The need to reduce python populations requires immediate action, but this work needs to protect native wildlife, which includes vulnerable species and essential ecological species. Every intervention creates effects that spread throughout different parts of the ecosystem. In the end, there are no perfect solutions, only trade-offs. Protecting the Everglades while managing invasive pythons will require careful planning, transparency, and a willingness to adapt. The real challenge lies in finding an approach that reduces affect while preserving the fragile web of life already under strain. Navigating this delicate balance sets the stage for exploring other strategies and the ongoing quest for a manageable, sustainable approach to the python problem. Searching for a sustainable solution. Controlling Burmese pythons in the Everglades remains a major challenge, pushing scientists to explore strategies beyond poisoned mouse drops. Hunting is still the primary method, removing thousands of snakes each year.
but it cannot keep up with the species' rapid reproduction. More efficient solutions are urgently needed. Detection dogs provide an effective method for pythons. Their abilities to find concealed pythons within thick plants exceed the detection capabilities of humans. The expansion of their deployment requires financial support, skilled operators, and necessary facilities, which currently do not exist. The second technique uses radio tracking to monitor female pythons that have been captured to locate breeding groups called breeding balls, which contain multiple snakes. The process enables specific snake removals, yet it requires female snakes to be captured and tagged, which makes extensive implementation unfeasible. Researchers are developing pheromone traps that will use female scents to attract male pythons. If successful, this system will require minimal upkeep, yet it remains in its initial phase and needs to protect other species from its effects. The experimental concepts focus on using biological controls and genetic engineering to decrease python numbers across extended time periods. The approaches show potential, yet they exist as theoretical concepts that present both ecological and ethical challenges. The existing methods fail to provide an equivalent solution that matches the urgent needs of poisoned bait. The method creates serious ecological dangers to the environment. Public acceptance represents another obstacle because previous biocontrol initiatives encountered strong public resistance. The most effective approach for the present requires combining various methods with advanced technology and executing management strategies that protect ecosystems while controlling python populations. The Burmese python invasion in Florida's Everglades is a daunting problem without easy answers. From mouse drops to detection dogs, each strategy carries hope and risk. As scientists work to balance ecological complexity with urgent action, the future of this unique ecosystem hangs in the balance. If you found this exploration insightful, please like and subscribe for more deep dives into the world's most pressing wildlife stories.